This video lesson provides a summary of our trigonometry unit. Okay, so this is sort of your guide for when you're looking at questions all mixed together as to what to do. So first, to solve a triangle means to find all the sides and all the angles. Second reminder is that in a triangle, if you're given two of the angles, you can find the third angle by the sum of the angles in a triangle theorem, or the idea that all angles in a triangle add up to 180 degrees. Also, in a right angle triangle, if you have two of the sides, we know that you can find the third side by using Pythagorean theorem. Okay, for the next couple, note we're talking about right angle triangles. So if you're given two sides, you're going to find one of the other acute angles, not the 90-degree angle, but the other two angles by using our primary trig ratios. This, of course, means using SOHCAHTOA. Another right triangle scenario, if you're given one angle and one side, you would be able to find another side by again using the primary trig ratios. So we remember the primary trig ratios again by using this term or acronym SOHCAHTOA. This means, the SO means sine of an angle theta equals opposite over hypotenuse. The CA is cos theta equals adjacent over hypotenuse, and the TOA means tan of an angle theta equals opposite over adjacent. Okay, so then we move from right triangles to non-right angle triangles. So the first one we learned about is the sine law. Okay, so we use this to find a side or an angle depending on what we're given in a non-right angle triangle. We sort of remember two versions of this sine law, but one of them would be sine of an angle A over side A equals sine of an angle B over side B equals sine of an angle C over side C. Now, it can be the reciprocal, the flip of that. If you're solving for a side, it's just a matter of how you set it up depending on what you're solving for, okay? And we use the sine law when we're given three things, whether it be two sides and one angle or two angles and one side, but the key here is that we have to have what we call a corresponding pair. Okay, so if we have a triangle, a corresponding pair would be referring to, let's say, this side with this angle in here, right? That is a corresponding pair, where the side is opposite the angle. And the last law that we learned about is the cosine law. Okay, and the cosine law is a little bit complicated. You need to make sure you have that formula and you put it on your resource sheet or your crib sheet. Okay, and the formula for the side that we're solving for being C, or the angle, would be C squared equals A squared plus B squared minus 2AB cosine of C, which is that corresponding angle to the side C. Okay, now we use this cosine law in two scenarios. The first scenario where we use this is what we call side angle side. So when we are, let's say, given a side, this angle in between here, and the other side. So it's sort of the contained angle in between two sides. So side, angle, side, we would be solving for this side down here, okay? The opposite one, the corresponding side to that angle. Okay, and the other scenario is when we're given all three sides. So all three sides are given, and we need to find an angle. In this case, you can be finding any angle you want, but let's say we wanted to find this angle in here. Okay, so those are the two scenarios where we use the cosine law. So now what we're going to do is we're going to take a look at a whole bunch of different triangles and scenarios, and your job is going to be to try to figure out, what do I use to start solving this triangle, okay? Okay, so I'm going to talk about a few of them with you, and then you're going to go ahead and do the rest. That's part of what I want you to figure out. And you can also go ahead and in that box, once you say what the tool is, you can actually also go ahead and solve for the unknown, solve for the missing x, which is a side or an angle in all the scenarios. Okay, so just to give you an idea of the thinking and how I look at them. So first thing I do in this first one is I look at this triangle. It is not a right angle triangle, so I'm not using SOHCAHTOA or Pythagorean theorem. Okay, so then I look to decide, is it sine law or is it cosine law? Okay, I have side, angle, side. So it's side, angle, side with the contained angle in there, and that's my hint right away that I'm going to use the cosine law to solve for x. Okay, so you'll go ahead, when you're working on practice here, you'll go ahead and solve for x in all these scenarios. Let's take a look at the next one. Right away, what do I see? I see a right angle triangle. So very important that you note that. You've got two sides given here, two sides, and you're trying to solve for the third side. So hopefully you're thinking right away here, this one is just Pythagorean theorem. Okay, let's take a look at another one. Okay, so when I look at this third one here, again, right away, not a right angle triangle, no SOHCAHTOA, no Pythagorean theorem. So my only options really are sine law, cosine law, or looking at just the angles. So take a look right away. I have an angle with a corresponding side. So that means I am going to use the sine law to solve for that angle. And we'll just take it one step further there. Since we're solving for the angle, it's always a good idea if then you just think about your sine law as, let's say, sine A over A equals sine B over B. So you only need two of the ratios there. You don't need all three when you're writing it down. So that's kind of how I'm thinking. That's how I'm going to go about this. So what I want you to now do is I want you to finish this chart. I want you to solve for all of the x's, all of the variables. And then you will go ahead and practice just a couple application questions again where you put it all together, but it's given in words.